friends, in this lecture I would like to explain another example based on the circular arches. Already in the last examples I explained based on the two hinged parabolic arches how to find the horizontal thrust on a parabolic arch. Exactly, a point load carries at the crown and at the same time UDL carries over the entire span. But here in this lecture I would like to explain another topic based on the semicircular arches. See here, we have to determine the horizontal thrust developed in a semicircular arch of radius r subjected to a concentrated load W at the crown. Here concentrated load exactly at the crown, which is at C, and both hinges are hinged. That is one at A, another at B. And at the same time, this is a semicircular arch which consists of radius r, and this is of full diameter. For example, we know circle consists of the full diameter, so which is 2 times of r. Okay, and at the same times, so first find out the vertical reactions at A and B. So general procedure only. So reaction at A and reaction at B. So already I explained the conditions. So find out, resolve sigma MA will be equal to 0. Take down clockwise moments one side, another anti-clockwise moments on the other side. Resolve this one. Force into distance RB into 2R, which is anti-clockwise. Similarly, force into distance, this W, force into distance W into R. If you cancel this one, you will get RB will be equal to W by 2. Similarly, some of the vertical reactions on the arch will be equal to 0. So RA will and RB will be acting upwards and W will be acting downwards. So already we know RB. So take down RA will be equal to W minus W by 2. So 2W minus W, which is equal to W by 2. So that is RA value. So here we can take down RA and RB like that, or else we also know one condition. So on a simply supported beam, if a point load is acting exactly at the center, the load will be distributed equally on both ends. Like that also you have to consider directly. So our first step is to find the vertical reaction at A and B. For example, if an UDL is acting means you will get WL by 2. So here it will be in terms of WR. 2R means you will get W into R. I will explain while solving the example based on the UDL. So after knowing this one, so we know the formula also, that is horizontal thrust will be equal to integral of M dash y ds by EI, and again denominator will be equal to integral of y square ds by EI. See here, EI will be constant on both, therefore you will get directly integral of M dash y ds by integral of y square ds. Then, so here we have to consider a point Px comma y. First resolve the part of numerator, that is M dash y ds. So what is this M dash? M dash will be the moment on the arch. So for that purpose we have to consider one point P x comma y. So here we have to consider exactly a section xx at a distance of x from A. So this is the section xx. So we have to consider this one at a distance of, so this distance y and distance will be x. So this is the section xx at a distance of x from A. Okay, then see here one more thing what I want to explain here means, so this is the circular arch which consists of radius. So in times in if it will be parabolic arch means here y value will be there, rise will be equal to, so r value will be there, which is rise, and at the same time full span length of L. For finding this y value, the formula will be equal to 4r by L square x into L minus x. This is for parabolic arches. Parabolic arches. But for circular arches, it will be small difference will be there. See here, this is of radius r. Wherever you can take, it will be in terms of radius r. For example, here it will be here to here means it will also radius r only. So this one will be radius of r. So you can take this one. So what about this distance from here to, what about this distance from here to here? What about this distance? And what about this distance from here to here? So see here, here this will be acting theta. So at some distance theta, it will be acting at a distance rp points comma y. So always theta opposite will be, this point will be r sin theta, and this one will be adjacent will be r cos theta. So how we will get this one? So we know this condition. So if it will be acting some theta means, and this will be radius r. So this is opposite side, this is adjacent side, and this is hypotenuse. So if you want sin theta, what you have to do? The formula will be opposite by adjacent sides. Opposite by adjacent sides. So I am taking opposite value will be equal to some x1 distance. So x1 adjacent will be this r. So if I want this x1 equal to cross multiply r into sin theta. Similarly, cos theta will be equal to adjacent by hypotenuse. This adjacent is y1. That one will be equal to y1 by hypotenuse is r. Cross multiply y1 equal to r cos theta. So like that you can remember directly. Whenever theta opposite, you will get r sin theta, this distance, and adjacent distance will be r cos theta. Okay. And one more thing, what you have to remember means, see here, here here to here the distance will be exactly from the center, it will be r, and here it will be x, here to here, and the remaining part will be r. Means total r will be equal to, sorry, this will be x and this will be r sin theta. Okay, so overall r will be equal to x plus r sin theta equal to this r. If I want x distance, r minus r sin theta, and again x equal to r into 1 minus sin theta. So the distance, this small x distance from here to here will be equal to this r into 1 minus sin theta. Okay, then so we are solving the numerator part, that is integral of m dash y ds. So what is y? This y will be equal to here r cos theta, r cos theta. And what about this ds? ds is the small elemental part, take down directly r d theta. So please remember this one, ds always in the circular arches you will get r d theta. And what about this m dash? For m, that m dash, that one will be equal to, so resolving this force ra into x, so ra into x. Okay, so that is the moment here. So what is ra? Ra will be equal to w by 2, and x distance will be equal to r into 1 minus sin theta. So take down entire numerator part, that is m y dash ds. That one will be equal to w by 2 into r into 1 minus sin theta is m dash into r cos theta is y into, so this one y into ds is this r d theta. Okay, here the limits will be applied taken from 0 to pi. So it is in the form of 0 to pi. So the same property, if it will be 0 to pi f of x dx taken due to symmetric condition 2 times of 0 to pi by 2 f of x dx. So if the function is even, so we know the property in the max, the same property we are applying here. So I already explained in the previous problem also. Okay, so this is 2 times of 0 to pi by 2. Simplify this one. 2 into w by 2 r. So r cube integral of 0 to pi by 2 1 minus sin theta into cos theta into d theta. So simplify the values again here. W r cube 0 to pi by 2 into 1 minus sin theta into cos theta d theta. So we know the how to solve this one. So first take down this entire 1 minus sin theta. Put 1 minus sin theta will be equal to t. So differentiate this t. You will get this one 0 minus differentiation of sin theta will be equal to cos theta d theta. So this is d theta. Okay. Here 1 minus sin theta will be equal to t. 0 to pi by 2. 1 minus sin theta will be equal to t into this cos theta will be cos theta d theta will be equal to minus dt. And again apply integration here. So differentiation of t with respect to pi by 2 will be t square by 2. So minus will be there here. Okay. That is 0 to pi by 2. Okay. And again simplify this one. So that one will be equal to, again I am writing the same value, and again I will differentiate here, minus t square by 2. Okay. Again take down the common term outside, that is w r cube by 2. Again what is t value here? That is 1 minus sin theta. So this is in the limits of 0 to pi by 2. So this is 1 minus sin theta whole square to the power of 0 to pi by 2. Okay. Then what is the next step here? W r cube by 2. So this is in the form of a minus b. So expand the term. 1 minus sin theta whole square means a minus b whole square. 1 square a square plus b square minus 2ab into 1 into sin theta, that is 2 sin theta. Apply the limits of 0 to pi by 2. So first to entire this term we are applying upper limit, that is wr cube by 2 minus 1 plus sin of pi by 2 which is 1 in terms of square also 1 minus 2 into sin pi by 2 sin 90 1, that is 2 into 1 1 only, again minus. So upper limit minus lower limit, and again what is lower limit? Entire this value, this minus value, minus into minus plus here, then 1 plus sin of theta will be equal to 0 minus 2 into sin of theta will be equal to 2 into 0. So simplify this one, how much you will get? Here minus 1 plus 2, again plus 1. So if you simplify you will get wr cube by 2. The numerator part will be equal to, so how much you will get? Integral of m dash y ds, that is 0 to pi by 2. That one will be equal to wr cube by 2. Okay. So you can take down directly integral of m dash y ds also. Then denominator part, that is integral of y square ds. That one will be in terms of 0 to pi, the same property, 2 times of 0 to pi by 2 y square ds. Again what is y here? 0 to pi by 2, 2 times of y is r cos theta in terms of square, ds is r d theta. So simplify this term to 0 to pi by 2 r square cos square theta into r d theta. Again 2 r into r square is r cube 0 to pi by 2 cos square theta d theta. So again you have to apply integration for this cos square theta term here. So for this one, what is the formula? So already we know cos square theta will be equal to 1 plus cos 2 theta by 2. First I will solve this one based on the property, that is sin square theta plus cos square theta will be equal to 1. We know this one. And again cos 2 theta will be equal to cos square theta minus sin square theta. So already we know these formulas. If I want this sin square theta, what I have to do? I will send this cos square theta this side, that is cos square theta. Sin square theta means 1 minus cos square theta. Okay, then simplify this one, cos square theta minus 1 minus into minus plus cos square theta. So this is 2 cos square theta minus 1, that is cos 2 theta equal to. If I want this cos square theta, what I will take? I will send this one this side, cos 2 theta plus 1 equal to 2 cos square theta. If I want only cos square theta will be equal to, send this to this side, cos 2 theta plus 1 by 2. So that is what I am saying here. You can take down directly the formula if you know. No need to solve here. That is 0 to pi by 2, 1 plus cos 2 theta by 2 into d theta. Okay, and again simplify this one. Take down this 2 common outside and cancel that one. R cube integral of 0 to pi by 2, 1 plus cos 2 theta do theta. Okay, then again I will split this term here and then I will simplify. R cube 0 to pi by 2, 1 into d theta plus integral of 0 to pi by 2 cos 2 theta d theta. So here what I will take means r cube integral of 1 into d theta equal to theta plus constant of integration, that is theta. Integral of 1 d theta means theta. So the limits will be in terms of 0 to pi by 2 plus integral of 0 to pi by 2 cos 2 theta. For that again what we have to take means, take down 2 theta will be equal to mu. So if you want to differentiate this u means du will be equal to 2 will be constant, you will get d theta. If you want du value, sorry d theta value, what you have to take means d theta will be equal to du by 2. If you see here, you will get the value 0 to pi by 2 cos 2 theta value will be equal to mu, d theta value will be equal to du by 2. And again I will simplify the remaining term here in this slide. I will simplify here. Okay, so only this part 0 to pi by 2 cos mu du by 2, that one will be equal to integral of cos mu will be equal to, so first take down this 1 by 2 outside, apply integration. Integral of cos mu will be equal to sin mu du, that is 0 to pi by 2. So what happens, this mu value will be equal to 1 by 2 sin 2 theta pi by 2. And again I am taking here, apply the integration 1 by 2 sin 2 into pi by 2, 2 to cancel, sin 180 degrees, 90 plus 90, sin 90 value will be equal to around how much you will get, sin of 180. Sin of 90 plus 90 means cos 90, that is 0. So here the entire time you will get this part is 0 and the remaining term is apply r cube theta pi by 2, lower limit 0 we have to substitute in theta, you will get pi by 2. So the overall value here you will get r cube pi by 2 plus 0, that one will be equal to pi r cube by 2. So this is the denominator part, what you will get, that is integral of y square ds 0 to pi by 2 2 times. So the numerator part will be equal to how much? We will check here. The numerator part will be equal to, so this one, WR cube by 12. So therefore horizontal thrust will be equal to integral of m dash y ds by integral of y square ds. The numerator part will be WR cube by 2. And what about the denominator part? That one will be equal to pi r cube by 2 by pi r cube by 2. So simplify this one, taking denominator and again this one outside. How much you will get? Cancel the terms. So you will get pi w by pi. So therefore the horizontal thrust will be equal to w by pi. So whenever on a semicircular arch, if a point load is acting at the crown, your horizontal thrust will be equal to, h value will be equal to w by pi.
Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.